We now have a model that has random effects, in this case, the results of coin flips in consecutive rounds of the game. We have a way to calculate how long the game is. In this case, the game has 7 rounds, and we have a way of calculating the final payoff. Now, in order to run a simulation, we first have to mark the outcome variable that we're interested in as an output. You see, there is a lot of calculations here in Excel, and how would the at-risk add-in know which output we're actually interested in? Why not the absolute difference in this, right? Maybe this formula we want to trace, right? Lots of calculated things. So what in order to mark the output value that we need, you see, we selected first distribution, now we select the output variable. So you go to the cell where we have the final payoff. This is the output that we're interested in. We want to know if we're winning on average or losing on average, and click output. If I click output, the at-risk add-in asks what's the name of this output, and it correctly guesses that the name is final payoff. If we click OK, again, all that changes here is that we have here in this formula added a risk output function. This function actually doesn't change the value. The value is still C3 minus C2 times C4, right? Calculating the result of the game. But adding risk output indicates to the at-risk add-in that this is the parameter, or this is the outcome variable that we want to learn about, right, through the simulation. So here again, it regenerated, and now we have 11 turns of the game, and we lose $3 on this particular game, but it's not one game that we're interested in. We want to simulate this. So the next thing we want to decide is how many iterations of the simulation we will do. Iterations means how many times this game will be repeated in order to learn about possible payoffs. Now, the default value is 1000. You can increase it, you can decrease it. Just as an exercise, I'm going to decrease it to 10. Normally, you shouldn't do this, but I just want you to show, I want you to see why very few iterations might be a source of problems. So if I change it to 10, I now want to go to simulate. So I will select the final payoff here and click simulate. And now the simulation is running, but it will be very quick, and it generates a few results for us. And you can see here a distribution of the results. Now, because the nature of the game, we actually can either win $5 or $3 or $1, or we can lose $1 or $3 or $5, as you can see from this distribution. And actually, in the 10 iterations that I asked for here, we have one game we lost $5, one we lost $3, two we lost $1, four we won $1, and one $3 and $5 we won. This should be a total of 10 games. So there is this result that we see first of all as a distribution, right? It's a very small sample. I'm going to close this, and now I will ask myself, if this is a winning game, how should I know? So remember, the data about 10 iterations of this simulation, 10 plays of the game, are generated and are not visible here, but are stored by at risk somewhere in Excel data. So now what I would like to learn is, if I'm thinking if this game is a winning game or losing game, the valid statistic that I'm interested in is a mean payoff. So let me actually start here a block I will call simulation results, right? And I can create here things like the minimum payoff that I obtained, right? And in order to enter minimum payoff among the simulation iterations, I can call for a function, and among the functions there are simulation results. And one of those functions is called risk mean. And if you select risk mean, and then it asks you risk minimum of what, the output that we are carrying a final payoff. Okay, and you see the smallest payoff we had, let's convert it to dollars, was negative $5. If you want maximum payoff, you can also ask for it. You can go to at risk and say function simulation results maximum risk max is here, right? And we want maximum of the payoff value. And again, you see the maximum is plus $5. Again, I need dollar formatting. And I will also, right, these are, of course, this is the range. So the worst that I had in the 10 iterations was I lost $5, and the best I won $5. But the interesting statistic, and I think this is key, is the mean payoff. Payoff. Right, a mean payoff, there is a function for it also. And actually, I can enter it by finding it there under functions. But notice these are just functions called risk max, risk mean. Well, I can enter this one. This is actually called, maybe I can even, yeah, I can enter it equals risk mean. Risk mean, and again, for the final payoff, right? And you see there is a mean value here, right, that I can format, and the mean payoff was 20 cents. So on average, we won 20 cents among those, across those 10 games, 10 iterations that we created, right? This is, I think, the key measure. Let me somehow highlight it, right? It looks like it's a winning game. I just simulated 10 iterations of the game, and I get, on average, I win 20 cents. So it looks like this is a good game for me. Now the question remains, is that a good enough result? Am I confident that this is a winning game, or maybe I should question the result?